Good afternoon, everybody. Thanks for joining us. It's a kind of an exciting time for us to be able to introduce this as something that's been in the works for quite some time. Our compact holographic 3D radar technology that we've been developing. So welcome. Today, we hopefully will be able to give you a good introduction, answer some questions, and best of all, show you some live demonstrations. I always like to do stuff live, and got Ken here. Of course, I'm Logan Harris, the CEO founder of Spotter. Ken
Gardner. I'm a account manager here at Spotter Global, been here since 2019. I held a few different roles, but these days I'm just kind of doing the sales stuff. So, but happy to be here all the same. And I've been here through the development of this for the last couple of years and seen everything we've done before, and looking forward to what the future holds with this kind of technology.
So with that, just kind of a few things while we're going through. We'd like to have conversations, answer questions. There's a little Q&A icon at the top of your screen you can click on. You can put questions in there. Or if you can't find that, you can put in the chat. Jamie, our communication specialist, will be monitoring those and bring it up to our attention.
We really encourage the questions. This is a lot more fun if we have kind of a back and forth on this stuff. So by all means.
Yeah, absolutely. We want to answer your questions. That's what this is about, is letting you know about something new, interesting, and then getting your questions to see if we make sure that you can see what we're doing here. So with that, we'll get into it. I'm going to set the stage a little bit of why we've been doing this. And it's really because the drone threat is changing and increasing in many different ways. In particular is drone swarms using technology that don't use RF. In the past, few years, most of it's been, wireless. RF sniffers have been pretty effective, using GPS for navigation. Both of those are, susceptible to being picked up by RF sniffers. And also with jamming, you can, jam their communications. You can jam their navigation with the GPS, and that's been fairly effective. But that all changed or started changing back in December of 2024. Since that time, you guys have all seen the news. These fiber optic drones are becoming the main battle weapon used in Ukraine.
Used in Ukraine, used in all kinds of different fronts, and it's very clear that it's going to become kind of a more pervasive threat going forward. It's not just a device that's available to militaries around the world. The kinds of devices that create this are available online for a few $100s. You can adapt any kind of drone. If you have a DJI, you can strap one of these kits to it for $300, and the average user, anybody who wants to, can take something that off the shelf would have been inaccessible 10 years ago, and nowadays create a guided munition in their garage that's being used by military forces all around the world. You can do it at scale for a very, very low cost. Like I say, 10 years ago, this was the kind of stuff that was the world of science fiction. And now it's a very real threat in warfare, and it's something that we're going to start seeing more and more everywhere you go. So this isn't just something that's accessible to foreign governments. This isn't just accessible to DoD level spending. This is something that a hobbyist can do in their house for under $1,000. So the threat is very, really, very, very real. And like I say, the mitigation techniques and detection techniques that we've had in the past, they're just, everything about this technology is made to subvert those past technologies. And that's where this radar comes in. It's a very direct technology that is looking for things that are not emitting any signal at all whatsoever.
Yeah, and to that point, I just brought up, you can search on, Alibaba for fiber optic drones. You can get this, and you can see, yeah, well, I can get a 30-kilometer, 50-kilometer FPV fiber, pack here for $300. So that's where we've gone from, just introduction of the technology in December of 2024. Within a year, a little over a year, they started selling this, en masse, and you can get it, anywhere. Anyone can get this. I mean, it's available. This is readily available. To Ken's point, anybody can get this.
Oh, hell, we've got some on order.
Yeah. we got to do some demonstrations. Got to understand.
We didn't have to go get a permit. We
Yeah.
didn't have to apply for anything. You just get online and buy it. So.
Yeah. So so that's coming, and then also we're seeing that now these are being used in conjunction of, is not just one drone at a time, but multiple drones simultaneously. And that is, whether I've, been seeing this happen in prisons where they'll send multiple drones in, one to kind of be the lookout, the scout, another one to go in and drop the contraband. Or if you're planning a real attack, you don't just put all your eggs in one basket. You're going to send in multiples. So that's where we're gone from is wireless single drones, and now we're looking at fiber optic guided drones and then multiples. And that's not just it. There's new other technology. You probably saw this, the spider web operation done by Ukraine against Russia, back last year. It was particularly successful where these drones were remotely launched using video AI, were able to then target these the bombers that were on the ground. And I mean, this is something new where now navigation, instead of using GPS, can use the video feed itself so that they can navigate regardless of having GPS.
Without any user involved, without any signal involved. I mean, it's because that comes down to just a video AI storage parameter, and an airplane on the ground is a fairly simple thing for a drone's video system to make out. And once you target that and zoom in on it, it's pretty much just runs on its own. It's not a pilot involved, and it doesn't have any kind of signal between the operator. It's just a standalone munition. Like I say, once it's launched, it's off on its own, and there's very few things that can detect it. There's very few things that can get in the way of it. But again, radar is still the old classic. It's been around for 100 years, and it's because it's pretty straightforward at the end of the day.
Yes, and that kind of gets into why we're doing this. Okay, so without the ability to pick up the RF, there's no emissions, then what do you have left? You've got sound and you've got reflections from a radar system. With sound, it's with acoustics, that has some usage, but it's particularly susceptible to background noise, rain. You think about a wind, things that could obscure that.
There are times when acoustic sensors are absolutely. I mean, we've all heard drones. They're very distinct, and there's a place for it in the world. But just like any other security solution, this is a layered approach. And there are places where the acoustic side will fail, and the radar makes up that gap. Vice versa, of course. But there's a very real play here. The radar is going to pick it up in areas and in environments where acoustics simply won't work. A lot of the times, urban areas are going to be areas that are going to be primarily targeted, and the background noises that come along in those spaces really have a hard time with acoustic sensors, engine noises, cars running.
Yeah, it's just practically impossible.
You put it up on a roof with an air conditioning condenser in the background.
Yeah,
that's going to drown out pretty much anything there. So, and in that instance, the radar is not bothered by that in the slightest. So,
but the other things is saying, what's compact holographic 3D radar? What does it mean? What does it do? And really what it comes down to is that we're trying to see the whole picture at a very fast rate. That's why I got this, 18 hertz up there. It's similar to how you would think of a camera system. In a way, we're mirroring some of the same operations of camera system, but doing it with radar. And that's what's unique about this particular device, is that we're approaching the problem so that we can see the full field of view 18 times a second. I like it to compare it to the difference between a floodlight, which illuminates the full volume of space 100% of the time, versus a flashlight. A flashlight is, you got a focus beam, and then to see what you want to see, you got to scan back and forth. Now, that might work if you've got a single drone, but if you've got a swarm of drones coming in fast, just think about how hard it is to be able to scan through that sky and be able to see your target.
Yeah, I mean, absolutely. It's when you look at the visual, it gives you a good idea of kind of what we're talking about here. But that's kind of the problem with a lot of the past radar systems and a lot of the things we've seen since we started doing the radar detection thing. I think what did we start 2015 with the AX250 system.
I
Or
first
some
filed for a
iteration.
patent back
Okay.
in 2014,
We've been,
but yes.
we've been looking at this for a
Yeah,
while,
yeah.
and past iterations have worked very, very well in compact spaces against small threats. And we were focused on things that were, again, moving a little bit slower on the commercial side. And we were looking at things that were usually coming at a more limited basis. But when you look at it from a warfare perspective, from people, from that evolving side of things, we've seen in the last couple of years, we've seen how people are changing their tactics and how they're using them, and what worked in the past is not working in the future. And like I say, scanning once per second on a rotation, there are places where that, again, it's always a layered approach. There's always a correct instance for the application. But on the modern battlefield, once per second, you move at 70 miles an hour, that could cover a lot of ground in a second. You don't have time, and you need to make sure you're scanning that full area as quickly as possible and as much of it as possible. And that's where this 18 hertz device comes in.
So let me explain that a little bit more deeper. So in a sense, we're waiting for like a period of time. So we're illuminating, instead of having a scan beam that we're scanning back and forth like electronically scanned array, we're illuminating, so we're emitting at a low energy, in fact, very low, the lowest in the industry. So it's practically in the noise. So, but we're emitting this low energy 100% of the time. And then we're integrating or kind of receiving, accumulating the reflected energy. So that's going out over a 56 millisecond period. So for 56 milliseconds, that's like our exposure time is 56 milliseconds, and we're receiving that reflected energy. And then at that point, we have what we call a frame, kind of like a camera frame. And then we analyze all of that reflected data for these, what we call interference patterns. And that's kind of from the holographic processing world, is that then we look at these interference patterns from all these multiple receive antennas that we have to then determine the location of the targets that are out there in the full volume of space. So that means not just one at a time, like you would get with the electronically scanned array, which is only going to look at one spot, like every 10 millisecond. And if it's got 180 spots, it takes 1.8 seconds to scan the full view. Instead, we are able to see, 50 drones or 50 targets simultaneously every single frame. That's what's really unique about this.
It's a substantial amount of visibility. Once you guys see it, that's really what tells the story, honestly. But when you consider the speed of the drones that we're looking to detect, if you're looking for a drone that's moving at 10 miles an hour, 1 hertz maybe cuts it. But when you're looking at things that are moving 70, 80, 100 miles an hour, you absolutely have to have an extremely high rate of detection. Otherwise, it's going to cover that space in a second. So
yeah, I'll show you a video here in a few minutes, and we'll show you some live drones flying around as well here in a second.
We've got a question here about regulatory constraints. Make sure we address that as well.
For this radar, it is operating in the 10 to 10.5 gigahertz band. It radiates at very low power, 3.2 watts EIRP. In that 10 gigahertz band, that does mean that you have to get in the US. It does mean that you get a FCC license, but outside of that, there's no constraints. It's very, it's legal to track targets in the air and identify those using radar. So the only thing you have to do is get a FCC license, and we can help you through that process. It does take, 4 to 6 weeks, depending on, what's going on. But yes, that's only regulatory constraints. Now, if you're out of the United States, there are some restrictions for us to export. It's not ITAR. It falls under the Commerce Department. It's an EAR 99 device with a special constraint. We can ship without an export license to 28 allied countries of the United States, most of all Europe, a few countries in South America, Korea, and a few others. Outside of that,
If you have a question, let us know and we can get the full list for you and double check.
yeah. So it's pretty, pretty straightforward to be able to access this technology. So here it is. Of course, we've got it in the background. Its field of view is 90 degrees in vertical, 90 degrees in horizontal. We're able to give precision targeting information in both what we call the azimuth or horizontal dimension and the vertical dimension, better than 2 degrees. So enough so you can get precision to Q camera or other weapon systems. And of course, at 18 hertz, so you have very low latency. Which really, critical from, Ken's point, is that if it's moving fast, you need an update rate that can keep up with it in order to be able to do something about it. Here's the dimensions. It's, pretty small, 16 inches by 10 inches by 4 inches deep, still about 8.8 pounds. So relatively lightweight, you can still put in a backpack.
It's not hard to carry around.
35 watts power consumption, active PoE, 3D user interface. And I think we're, kind of comparing it here side by side to electronically scanned array. MSRP is just under 50K. And we're looking at a range of, 500 meters on a 3 kilogram drone. Where we're really standing out, of course, is our field of view volume scan rate, not just the track rate. And that's sometimes how it's written into specs is not really the full volume, but how fast the track is updated. So 2 different things. This is the full volume, being able to see the full volume 18 times a second. Angular resolution, like we've covered that part. So let's get into some of the fun stuff. Let's go look at the actual radar here. And
Cassie, can you hear me?
So
You ready to fly?
This is the user interface.
All right, fire when ready.
This is the user interface. Right now we're playing a replay file here. We're going to get a live system up and running here shortly, and then we'll switch over to our live radar. As you can see, you can move in and out. You can see from the first person view how the system operates. You can look top down, bottom, rotate around in it. So it's really nice user interface here. Let me switch over here. So we got the live system coming in. You can see how fast the update rate is occurring. And we've got that. So this is able to take a look at all the different sides of it here. And let's see, got that one on. So let me switch over here. We've got it side by side. Now you can see the 2 different tracks. One is the remote drone ID track. That's the one on the red. The one in the green, that's the drone ID, or from the GAX 500. We're doing a comparison side by side with that. And that's okay. All right, come on back in.
You got that, Cassie? Thank you.
All right, so now let's get this one over. So this is the live radar system right here. Let's turn on elevation, coming in at 85 meters high. We can look at it, of course, from the top down, kind of 2D view. This is the range, and we can switch over. Here's coming in on the networked IO. We're queuing the camera onto it, as you can see here. I know I'm throwing a lot at you right now. We'll take it kind of step by step here, but You can see the drone coming in. This is our new version of Network.io that puts the kind of the track icon, replaces that with a chip from the camera that is identified by the video AI. So let's go back over to our 3D radar here. If when you come to a stop, it does, can still drop off the radar because it's moving, it's tracking moving things. Go ahead and go back out.
Copy.
Very good. All right, so there we go. Let's take a look from the top here. And I can put up my track information here so we can see how fast it's updating. And each one of these rings is about 100 meters. So you can see we're tracking, this is a Mavic 3 that we're tracking out past 300 meters. We're getting almost 400 meters. It's like I said, it's spec'd at 500 meters for a 3-kilogram drone. We're doing really good on this flight, past 400 meters here. And it looks like we got past 400 meters on that one.
Petered out there, but that's pretty good.
Yeah, but that's
A Mavic.
that's pretty good for a 1 kilogram. A Mavic is less than a kilogram, so it's about 2-pound drone. So that's pretty impressive.
That's
right
one of
there.
the little quadcopters that everyone's kind of familiar with. If you're a hobbyist, or most of what you're going to see flying around at like a state park or something, that's usually what you see.
Okay. Why don't you come on back in?
Copy.
All right, here it comes back in. We can see on our 2D view here, picked it up past 300 meters.
Could we pull up the Neo as well? I kind of want to elaborate on these chips here on the snapshot.
Sure.
This is something we've just come out. This will be available on Neo 6.2, and I'm a big fan of this. In the past, it's always been, we kind of try to track it with the camera, and the camera will, it'll do a pretty good job keeping up with the field of view, but it's not the best user interface. With this, it really takes those chips and it takes the best parts of that camera view. It puts that video AI around it, and it pulls it out and puts it right in front of you in a way that is really, really usable. It just separates the wheat from the chaff in a way that it just takes the useless stuff and makes it so you don't even have to see it. It puts that information that you need front and center. There's no question about what's being tracked. It's just, from my perspective, this is something that if we could have been doing this 10 years ago, that would have been fantastic. The technology just wasn't there yet.
Yeah, I mean,
but this has been a really big jump that we're next release. I'm really excited about this.
Yeah, I mean, I know we're getting a little bit, talking about some other things, but I think it's a good point that Ken is making here. And it is with the ability to do both radar AI as well as video AI allows us to do things like this. Because now once we know the position of the target in the sky, we can then cue the camera onto target, and then you can go ahead and fly back out, Cassie, another time if you could.
Copy.
So this allows us to then have the video analytics focus into that particular target, grab the piece of the image that is relevant, and then render it onto the map. So now that we can see all the targets that are happening simultaneously across the whole site. So if we wanted to, we can see the ground targets as well.
That video image that you're pulling that out of, that field of view that you're pulling that out of, it's a substantial field of view, but it's just picking that cube out of it that you actually need to see. And it gives you all the information. It shows you what it is. There's no question about whether it's a bird flying out there or something. You just have the item of interest and you can look directly at it. It is phenomenally powerful compared to what we've had in the past.
Yeah, and I can show you this a little bit. If I go in, I'll switch on some of my ground. I don't think we've got a, well, here we are. We've got a ground.
Yeah, it does know the ground stuff as well, which is pretty great.
There you go. So now we're tracking both the ground targets, you can see here, simultaneously. So you can get the full, let me close this down here so you can see this. So this is something that's, particularly unique, is the fact that we're now identifying and tracking both ground and air targets simultaneously and viewing that from a single view.
Yeah. I say this is a technology integration that, in the past we pulled in the camera feeds, we got the snapshots. You'd have to kind of go back through them and kind of sift through everything to see what was where. This puts it right in front of you in a way that, like I say, it's very, very actionable. All of a sudden you can make some quick decisions.
So there we go. We're seeing both air and ground and drone, and I'll show you a little bit here in a second. But we're also getting ADSB. But let's answer some questions.
Yeah, I think what I was going to say. I thought we had a few there. How far up are we?
So yes, for the presentation, we will be putting this webinar online and sharing that with you, so you'll be able to do that. If you're trying to get additional like case studies and other things, reach out to Jamie, and Jamie, if you can post your email, she'll be able to help you out with that. Okay, the other question is, do you integrate with C2 solutions like ATAC or Unify?
Yeah, absolutely. ATAC we have for years. This is Neo. So Neo has been in existence in one form or another for what, 15 years or so at this point.
Yeah, we started in 2012.
Yeah, so it's a pretty old technology, relatively speaking. In that time, it's nothing like it was when we started. We've added so much to it, but one thing that's been a constant throughout that time is the requirement to integrate with downstream systems, other C2 platforms, VMSs. So ATAC, absolutely. Unify for sure.
Well, ATAC uses cursor on target. That's what I've got on the screen here.
Yeah.
You can output cursor on target. So it's just a matter of attaching, okay, what type of targets you want to fire this action, and then you can, assign it to a zone, to set of filter characteristics. Say, I want to do this on drone or people, and then you can output it to wherever your host and port are. We've also added some other different outputs, like for instance, we're doing this one. We have these.
We've added some stuff since I looked.
Yes, we've added quite a bit. We've added outputs to Video Expert, Vigilon, Digifort, Exact Vision, FLIR, Milestone. These are all event packets.
You got a bird on that.
Oh, we got a bird.
So again, I mean, that's what you want. So
Yeah.
you can verify if you use it, if it's something useful or not.
Yeah. Yeah.
So, but yeah, we integrate with pretty much any of the major VMSs. Like I say, it's this is the security industry. Nobody ever got ahead by being in a rut. So.
And then we can create just kind of like generic network actions where you can just define whatever your whatever your protocol is you want. You can just, it's configuration, so it's not really programming. At the beginning of or when that rule becomes true, like when it alarms, then it can push out that data over to your system. And if you're wondering, why we're changing here, we've got two different cameras. We've got an Axis camera and Honeywell thermal camera. Their new Honeywell camera is pretty kind of a cool thing. As you can see here, I'll pull up the actual view so you can see what we're looking here. It's a thermal camera with high resolution and zooming capabilities. And so when it gets a view of it, it'll switch over, and then some of the times it's going to switch over here between that and the Axis camera. As you can see, it's kind of a wide field of view. the video AI identifies it. And then when it says, okay, I've got a target of interest that meets my, classification level, then it will go ahead and use that in the chip, which is really helpful. So you can see it it got it flipped over onto the thermal side, thermal, and then flip back to the optical once we got a good, image on the optical. So that's why you see it flipping back and forth there. That's one way to do it. Let's go flip back over to the radar side. Some more about the radar. Some of the same basic things apply to it that you're used to on a radar system. The UI is completely different. It does have some of the same things, but it's a complete rewrite, and hopefully it'll be a little bit more user friendly. Of course, it's got an updated look and feel, and with the 3D view and the 2D view options that you can switch between, setting, doing different settings like the track labels. I can put on speed, angle to target, so you can see that. I can adjust the size of that to make it easier to view for everybody. Let's go to 20. Maybe go up to 20. There we go. So you've got a lot of functionality there. We can extend the trail length. We can make the trail width bigger. It's a lot of good things to make it, a little bit easier for the people to view that. Everything is set up, and you can say what you want to see on the track cards that we're looking at here. So let's pull a track card up, and there's tracks cards. And these are a little bit different. You'll see these track cards in Neo. Now we were, having the same type of track cards in Spotter, and you'll see that all of our user interfaces are coming together. So that this is kind of the wave of the future, both for Spotter as well as for Neo. We've got another question.
Radar systems are suitable to assemble on unmanned marine platforms. I would say generally it depends.
Generally depends.
Yeah, that's the caveat. Radars like to sit still. That's kind of the biggest thing there. It's just like when you consider from the perspective of, think of it like trying to shoot a rifle from a moving platform. It's easier to aim at your target if you're kind of sitting still. If you're moving up and down, bobbing around, then it's going to change the relative position of everything downwind from that. So depending upon what your platform is that you're thinking about using, possibly, I know we've had like some offshore oil and gas rigs and stuff that we've been able to operate off of successfully.
Even buoy systems.
Even buoy systems, yeah. If something's relatively stable, but if you've got a ship moving through open water, as it is right now, the radar, if it's moving its position, it would need to update as well with that. And right now, as it stands, the program doesn't actively correct its GPS position as it moves through the map. That being said, the remote ID system could be utilized off a moving platform. You'd have to update a large enough map area for it to be appropriate, because the remote ID gets its GPS position from the drone itself. The drone is kind of self-reporting on itself. That information is not relative to the fixed position of the device. It's always being updated, and it's always accurate. So that technology could be used on a moving platform.
But hesitate to talk to us more.
Reach out to us about it. That's something we've been really exploring from a lot of different perspectives over the years. It's a common request. We haven't really found the right use case to kind of justify that R&D that goes into updating that. But it is, I think we kind of know how we would do it if the use case were correct.
And I'd like to point out, as you can see, that sometimes we are also picking up some other targets. We do have birds that are flying around. Crows. We got some hawks and also some turkey vultures that are around here.
Yeah.
And with radar, and we are able to pick up, track targets, all moving targets, including birds. But that's why also having coupled with video analytics is an important enhancement to the system.
It's the big advantage. It's also the disadvantage. There are that you do get false alarms. You get alarms off everything that moves with radar. That's where Spotter is so powerful, because so much of what we've done over the years, like I say, 15 years of development on that NEO platform, overwhelmingly those efforts have been in pursuit of mitigating false alarms as they are associated with ground targets, and when we started doing aerial targets with those as well. It starts at the radar edge itself and making sure that we set the sensitivity appropriate to each environment. Going from there, there's an initial level of AI that goes on at the edge of the radar. The NEO itself has a radar AI built into it that's even denser. You train that program so it tells the difference in each individual environment once it's on site. And then now you have that video AI layered on top of it. And then beyond all that, you have the filtration method. You have tons of different filters. I think we've got like 20 different filters at this point.
Yeah.
All options that you can utilize to say, hey, this is or is not a target of interest. So it is overwhelmingly NEO is targeted at trying to make sure that you're only seeing what you want to see and nothing else. That is really the strength of Spotter.
And one of the things, because as we're talking about, security and solving the security problem and the layered approach, it's no different with the GAX 500. The GAX 500 gives you, just think of it as it gives you a wider field of view. It's able to see more, but at the same time, as you are able to see more, then you need to be able to understand more, process more. And that's where the networked I/O comes into play, is to be able to analyze all that data coming from multiple systems simultaneously to say, okay, is this a target that is of interest to me? So we got another question asking about the actual sector for drone detection. It's more of elliptical coverage area, and if you look at this system right here, it's let's pull this one up. You probably see it better on maybe this one right here.
Yeah, this is always a difficult one to
Yes.
visualize.
Yeah, so it is kind of, the coverage area depends on the size of the drone. First of all, for a 3 kilogram drone, that's 500 meter range, and it's elliptical coverage area. As you can see here, it's more of an ellipse rather than a cone, because it's kind of the shape of the beam pattern, which is stationary. So we're not scanning the beam. It's just the illumination or radiation pattern of that beam, which is more of elliptical shape. So it's a 500 meter long by about 500 meter wide circle of coverage for a 3 kilogram drone. And then for a smaller drone like the Mavic here, it's a little bit smaller. So it's, we're tracking about 400 meters, which is really good.
Yeah, it's one of those things that, because of the hardware that's internal to it, and we're not setting an arbitrary stop to it with a scan. You got to kind of set an arbitrary stop to it with where we advertise it at, and so you have to pick a size of drone and pick where it does technically kind of work and work not at, and advertise it appropriate to that. Then we've settled on a 3 kilogram drone, and that's the standard that we're going with. Like I say, there's bigger ones out there that could detect a little bit further beyond those lines. There's smaller ones that would restrict a little bit more, but this gives you kind of a good general idea of what you're going to get out of it.
Go back to the video AI one.
I like the video AI.
Yeah, that's still kind of cool.
The video AI has made the optical like borderline more useful than the thermal. At night, it's not the same. At night, absolutely the thermal's the win. But
yeah,
during the day, and particularly we got a good cloud day, so the optical is looking really good out to range. We always kind of recommend a bispectral camera with these things. Like I say, at night, the optical is all but useless. And if you've got an overcast day with the wrong color drone, you can't see it at all on the optical. But like I say, on a nice day like today, we got a good blue sky for background. So you get a real nice, crisp, clear picture off of it.
So another thing I would like to point out while we're doing this is that we're able to have both, uh, in addition to, and Ken brought this up kind of when we talked about the unmanned platform, the moving platforms, is another technology that we've also released last year, which was remote drone ID. And with remote drone ID,
Sorry, I jumped dark there a little bit, didn't I?
yes, but with remote drone ID, this is another technology to pick up kind of commercial off-the-shelf drones. It's the run-of-the-mill, drones that people buy, DJIs.
This is not for the Russian military drones.
No, no.
But they're a nuisance all the same. And naturally, there's been a ton of questions about it. Drones have become a huge nuisance in the last 10 years as they become readily available to consumers. The price has gone way, way down. Everybody's been somewhere where a drone was being annoying. Overwhelmingly, the question is always, hey, what can we do about this? This thing's either hovering over our house and it's being annoying, or it's near to, if you're electrical customer, it's why is this thing near our substation, or it's you're a police department and you're getting calls from people and they're saying, hey, we've got a drone near this event, what can we do about it? And the answer is always, yeah, there's a drone there and we can see that it's there, but there's very little mitigation that can be done. Outside of the Department of Energy, I don't know that anybody has a lot of available use for the drone jamming devices. They're outlawed by the FCC overwhelmingly. And there's only a couple of states where you can have any kind of right to shoot it out of the sky. And I don't want to be the first guy in court trying to figure out what the limitations of that law are. But what you could do theoretically is if you knew where the operator was as a police department or an authority of some sort, you could go and talk to somebody about it in just an old-fashioned investigative way. And that's where remote drone ID comes in. The remote ID is a system that was mandated by the FAA back in March of 2025. I think it was a little bit before that, kind of started getting grandfathered in, but it was a hard stop in March. And all drones being flown within the continental United States are required to have this emission that tell you where the operator is, where the drone is, the make and model of the drone, the serial number of the drone, and that's all being transmitted out by the drone, and very similar to how an ADS-B transponder transmits all that information out on an airplane. The remote drone ID device that we have takes that information, plots it on the map, tells you where the operator is, and gives you this nice, clean graphical interface. It does it at a very, very low cost, and it does it at a range. What's really great about it is the range. The range on it is, I think the Rev one that we had, we said 750 meters radius from its installation point. I have one of these on my house as a beta test model, and I'm routinely getting ranges in the 2 kilometer range. And as I understand it, the Rev 3 that's about to come out, we're going to have a range of 4 kilometers.
It will do that.
That's what we're, and it's an antenna, it's listening. So it's a passive device. There's no emissions with it. It's very installation dependent. If you have a very flat area, then obviously it'll go further. If you have it higher, it'll go further. But mine's located 3 feet off the ground because I don't like climbing ladders to get it up and down, and it's still seeing 2 kilometers sometimes. So I would say, again, it starts at $15,000 total cost of ownership out the door, no subscription associated with it. It's not going to get every drone out there, but it's a fantastic device as an opening gambit in the drone detection space.
So now you got a little introduction. I was just kind of pointing out, so we're picking up that drone with our remote drone ID as well. You can see that we're pulling its ID out. We're seeing the location of the operator. And when we do that, you can click on the directions and it's going to show you how to get there. I didn't
know we could do this. Are you kidding me?
Yeah.
That's nice.
So they'll give you directions to where the operator is. So you can send that link off
that's a new thing.
Yes, that is a new thing. We got a comment here that DHS is going to post the rules about mitigation. Yes. So part of the NDAA, there was a Safe Skies pilot program that was initiated that says that, federal authorities can delegate their drone mitigation authority down to the local law enforcement and state enforcement after they've gone through a certification step of training. So that's a game changer as well, because now it's not just these 5, federal agencies that can do something about it. Now that's going to be, deployed much greater. And I think a lot of that is trying to, prepare for the FIFA World Cup coming up.
Absolutely.
And
that's a huge motivator.
You got to have a lot more, boots on the ground with the capabilities to do something about it, because
the government moves slowly at the end of the day. They always have. They've never been quick about anything. And every year there've been a little bit more. Yeah, Cassie's landing for a battery change. But
well, maybe that's a good time. I can show you this here.
But yeah, as things have gone on and as something's on fire over there.
Yeah, let's pull this up. I got to zoom out a little bit so I give you some context here. So that's the other thing that's in in NEO 6.2 that's coming out is the ADS-B interface. So for those who aren't familiar with ADS-B, it is a kind of like a beacon system that all commercial aircraft are required to carry.
Yeah.
And so now we can also monitor. This is an internet-based service. So for a small service fee on a yearly basis, you can see the commercial aircraft traffic that's flying around your site.
Yeah.
And alarm on it, just like you do any other track from NEO. You can see information about it. We can get the hull numbers.
More importantly, if you have like a small airport or say you have a helicopter landing pad at a hospital, any place where you have flight restrictions, that track with that airplane on it will show up in the same airspace as a drone. And so if you have a drone intersecting with aircraft, you can create an alarm that, says, hey, you've got a problem here. You can communicate that to the pilot, and you can get out ahead of things before you have a midair collision. That's going to be incredibly powerful.
Case in point, I was alarming. I have a separate zone, an airspace monitoring zone here. Let's say, okay, have this zone that I want to know if there's any aircraft that are, less than 150 meters from the ground, which is 1,600 meters in this area. And so I said, because I want to know if there's any potential, collision, that could occur if there's drones flying around. So I set up an alarm that says, okay, if there's anything in this zone that is less than 1,600 meters, alarm on that. And sure enough, yesterday, I got an alarm off of that right here. And you can see that a helicopter came flying in, landed at this area right here. And after a little while, took off and, flew out, went up the canyon. At the same time, we were having somebody here with a drone that was flying in this space. So
that seems like the sort of thing people would want to know about.
And all at the same time, this whole system was also monitoring all of the ground traffic, people and vehicles. Right now, I was just filtering, looking at just the airspace. But if I want to take a look at all the tracks, I can see everything. And I can see all the things that have alarmed that's in my area here over this period of time. And that's kind of the power of all of this coming together, is now that you can see both. Let's see, we got another comment. It looks like Joseph here says he's got the cert, but he still doesn't have the authority until they post the rules. So that's a good update. Thanks, Joseph, on that. And until they do that, yeah, we're, obviously this is kind of just developing as we go here.
Yeah, every year it's going to change a little bit more, but they keep giving us new tools. Like I say, remote ID was a big step forward. That was something that people have been asking for. How can we see these drones? How can we do something about it? In the past, we didn't have any tools, but nowadays, like I say, being able to find out where the operator is a huge advantage to local law enforcement, and a device that's not expensive to own, that is not expensive to operate. These things run on PoE. It's just a Cat 6 drop up to the roof of your building. If you can put a camera up, you can put one of these things up.
Yeah, it's PoE++ for this 35 watts, but we have an active PoE version or a passive PoE version. So it'll fit within your existing infrastructure if you're familiar with IP cameras or if you've used our other radar.
It's simple network architecture. It's not, there's nothing about this thing that's rocket science. And like I say, very low cost of ownership. You're not going to have issues with the FCC. It's just a passive device, but it gives you some authority. It gives you something actionable that you can go out and do things with. Even in the past, even with, if you just had the ability to detect things, you may not have the ability to do much about it. It was usually just kind of an investigative thing and an evidence-based thing. But knowing where that operator is, that is a huge game changer. Like I say, it's just something new. It's amazing.
So we got another question from Ryan saying, do you have any autonomous drone companies integrating with this device for detecting and actively avoiding other airspace operations? For the GAX 500 3D, not yet. Most of the initial interest or kind of the initial customers of this has been military base looking for queuing weapon systems onto drones because of the high speed nature of it. You definitely can use that for it. You think about it, especially if you're looking in areas where, they're seeing flights that aren't being picked up on the remote ID, remote drone ID.
You really have two systems here. One of them is very commercial and being looked at kind of it's not entirely within the continental United States. Remote ID is definitely a signal that's being adopted worldwide. It seems to be every year a couple of new countries pick up on it. But the GAX 500 is pretty specifically targeted at the DoD. People that are looking at those fiber optic drones, people that are looking at swarms, people that are looking at things come in really, really fast and trying to do some damage. So you've got, like I say, you've got two different use cases there, but they complement each other very nicely.
Okay, we got a question in if Lithuania and Latvia are involved. I believe so. I think we would need to check the list of 28, but
I can go back and find the list.
I believe that's correct.
You keep talking, I'll figure it out.
Yeah, Ken's checking to give you kind of a,
Post that on the FSE or in the
I did
chat.
I did that a little while ago. So we'll get a more precise answer on that one for you. The other thing I wanted to kind of like to talk about is that with the GAX 500, besides integrating into your kind of your normal, infrastructure, is that
Latvia and Lithuania are included on that list.
Oh, good. So yes, you got your answer right there. They are included. So
you didn't think I'd be that quick, did you?
Yeah, no export licenses involved with this. The other thing I wanted to point out with this is that because it has a wide 90-degree field of view, it can track both ground targets and air targets simultaneously.
Yeah, that's on the DoD side, that makes a big difference. Say in the past, our aerial stuff was pretty much targeted aerial stuff. There was a real difference there. This really slims it down to just one piece of kit that you can do two jobs with, and that makes a huge difference on the battlefield.
But also in critical infrastructure. I mean, that's another thing to look at is if you
can only have one device instead of two, that's always a winner. So
yeah, so less infrastructure, less cost.
Fewer points of failure. I mean, it pulls in more information more cleanly. If you don't have to aggregate it on the back end, it's easier if it's all just coming from one sensor too.
And obviously, there are some constraints, like for instance, I wouldn't recommend putting this into an area where you've got a really busy, volume of space. Like for instance, if you've got hundreds of people walking around.
Yeah, would it be correct to say that maybe you don't want to use it as primarily a ground sensor? It's like a aerial sensor plus ground. But if you're really interested in the ground, we have radars for that.
Yeah,
and that you should keep that in mind. Don't just pick this and shoot it at the ground.
I would say if you're looking for both air and ground, that is a good sensor.
Yeah.
In areas where you don't have a whole lot of ground traffic. I mean, like,
Yeah.
because you just think about it, you know.
If you can only pick one sensor, this is the one to pick. But if if you've got the option, particularly if you're at a fixed location and you know you're going to be there a while, you have the opportunity to use a specialized sensor for each environment. It's good to use the appropriate one. Bring the right gun to the right fight.
Because we're looking at doing stadium protection, and where there's a lot of people be coming in into a stadium area, I wouldn't be positioning this radar to see that area, because then in essence I would be kind of overwhelming the system from seeing the target I want to see. So I would place this radar closer to like the top of the building, so it wouldn't see the ground, but rather up in the air. That's how I would use that. So there are there's some of these things that you have to take into consideration as you're doing a design for a system. We have a service group with trained certified designers, as well as installers and commissioners, to kind of help you through that process. But that's why you do need to kind of have an understanding of how the technology works, how best to position it, and how to use that and integrate that into an existing system.
We've been around since 2008, 2009. We've got over 20 different ground radars as an option. We've got a couple different aerial radars that we're fielding at this point. We've got the remote ID system. We've got a lot of different hardware technologies available. We don't present the illusion that one size fits all. That's why we got all this stuff. So each one has its use case. There's appropriate environments for some things, and sometimes that's going to be inappropriate for them. And we've got something else to answer that question as well. So that's part of the advantage of working with Spotter, is we've got the years of experience. We've got the hardware to back it up.
All right. We've got just a few minutes left. Jamie's putting a plug in there for our LinkedIn page. If you want to get
and more questions too.
Updates,
more questions.
You can go there on our LinkedIn. Any more questions? Did we answer all your questions and then some? I know we covered quite a bit, in terms of the whole system and the GAX, how that all fits in. All right. Well, with that, I think then we will be wrapping up this. Appreciate all of you for your coming and attending. Thank you for the questions. Don't hesitate to reach out to any of us. You can always go to our website at spotterglobal.com. I'll show you something that you might like. You can always click here, schedule a call, and you can see great picture of Ken here.
That's pre-mustache.
Yeah. And you can schedule a meeting with any one of our service engineers, as well as our sales engineers here. You just click on the schedule now, and you can see the availability, schedule a meeting. Come talk to us. We'll be more than happy to talk about your particular security concerns and how we might be able to to do that. Yes.
I am young. What are you talking about?
So anyway, come connect with us. We'd love to help you out. Thanks, everybody.
Thanks a lot, guys.